I am going to discuss the problems on time varying field. This is the second session. Already we have discussed one more session. So to now I am discussing on the problems on time varying field. So what we have to discuss today. So just a quick recap of the last class. We have discussed about the Faraday's law. What is Faraday's law? We have discussed whenever a conductor is placed in a time varying field, an electromagnetic force is induced, and if the conductor is closed, which is called the induced current. Problem number 5. The magnetic circuit has uniform cross section of 10 to the power minus 3 meter square. If the circuit is energized with a current I1 ampere in the coil N1 is equal to 200 turns, then the EMF in the coil we have to calculate, and the N2 is given 100 turns. So in this problem, the resistance is given as 0.1 centimeter. So we can think this is a circular path. This is a circular path whose radius is given as 0.1 centimeter, means 0.1 into 10 to the power minus 2 meter. Some conductors are mounted on it. Some conductors are mounted on it. So R value is given as 0.1 meter. What is the cross-sectional area? The cross-sectional area A is given as the 10 to the power minus 3 meter square. So what is the current I1 is given as 3 sine 100 pi t. So how to get the flux? Flux is equal to current by reluctance. What is I? I is nothing but the current by reluctance. And what is the reluctance? Reluctance is nothing but the, what is reluctance? Reluctance is nothing but the N by L. So we can write what is reluctance? What is reluctance? Reluctance is equal to mu naught L by A. So what is the value of the L? L value we can get from the L value, or 1 by mu naught. From where we can get the L value? L value is equal to 2 pi R. What is R? R is equal to 2 pi. R is 0.1 into 10 to the power minus 2. So from here we can get the phi value. So what is EMF? EMF is equal to N d phi by dt. So what is the N1? N1 is given as 200 turns. So 200 into phi. Phi is I1 by R. If we solve it, we will get the flux value d phi by dt. If we derivative it with respect to t, we will get the E1. So what is the EMF induced in the second coil? How to get it? E1 by E2 is equal to N1 by N2. N1 is 200 turns, N2 is known. So if we put the value, we can get the value of the E1 by E2. So what are the terms? First we have the cross-sectional area 10 to the power minus 3. So how to get the phi? Phi is equal to current by reluctance. What is reluctance? Mu naught L by A. What is L? L is a circular path, so it is 2 pi R. Radius is given in the problem 0.1, so we can write 2 into 3.14 into 0.1 into 10 to the power minus 2. What is A? A value is also given, it is 10 to the power minus 3 meter square. So what is I1? I1 is equal to 3 into sine 10 pi t. So from here, if we put the I1 by reluctance, where R is equal to reluctance, not resistance. Remember this. This is the reluctance. So if we put the I1 by R, we can get the value of the flux. So what is E1? E1 is equal to N1 d5 by dt. N1 value is given in the problem 200 tons. One thing I forgot to tell here, mu is not mu naught. The mu, in the place of the mu naught, you have to write mu naught mu r. And what is the value of the mu r? Mu r value is given in the problem is 500. So if we put that, then if we want to calculate the E2, E1 by E2 is equal to, N1 by N2. So 200 by 100, we can get the value of the EMF. Next, we will discuss the next problem. What is the next problem? A square loop of 25 cm into 25 cm is placed in an alternating field with the maximum intensity of 1 ampere per meter. If the plane of the loop is perpendicular to the magnetic field and varying at a frequency of 10 megahertz, find the induced EMF in the loop. So how to calculate this? A value is given 25 into 25 centimeter square. So 625 into 10 to the power minus 4 meter square. What is H? H is equal to 1 ampere plus by meter. So what is B? B is equal to mu naught H. So what is mu naught? 4 pi into 10 to the power minus 7 into 1 ampere per meter. So it is coming 2 pi into 10 to the power minus 7. What is phi? Phi value is no. B into A. B value is given 4 pi into 10 to the power minus 7. What is the value of the A? A value is given 625 into 10 to the power minus 4. So it is coming 25 into 10 to the power minus 9 Weber. What is the frequency is given? The frequency in the problem is given as 10 megahertz. So F is equal to 10 megahertz is equal to 1 by T is equal to 10 into 10 to the power 6 hertz. So E is equal to d5 by dt is equal to 25 into 10 to the power minus 9 into 10 into 10 to the power minus 6. If we solve it, we can get the value of the EMF. Next, we will discuss the problem number 9 first. So, what is in the problem number 9? In the problem number 9, determine the conduction and displacement current densities in a material having a conductivity of 10 to the power minus 3 ohm per meter. Epsilon R is equal to 2.5. If the electric field in the material is 10 into 10 to the power minus 6 sine 10 to the power 10t, 10 into 10 to the power 20 volt per meter. We have to calculate the conduction current density and the in the displacement current density. So first we will discuss what is the current density. Current density means when the current flows through any circuit, there are the two types of current density. One is the conduction current density, another one is the displacement current density. When current flows through any conductor, we can write it by the conduction current density or JR is equal to current through the resistor by A, and the value always comes sigma into E. What is sigma? Sigma is the conductivity, and what is E? E is nothing but the intensity. Another current is when the current flows through any capacitor, there is some displacement current. What is the meaning of the displacement current? Displacement current is d by d into dt. What is d? D is equal to epsilon into E. So what is the dt? D by dt into epsilon into E. So this is the epsilon into E. JR into JD. JR into JD. So D is equal to epsilon into E. Now, if we want to calculate the field intensity E, then we can write that current I is equal to total current density J is equal to J at plus JD. In this problem, we have to calculate the conduction current density as well as the displacement current density. So, how to calculate the conduction current density is equal to sigma E plus JD by dt means d by dt into d. d by dt into d. So, it is sigma into E. What is the value of the E? 10 into 10 to the power minus 6 means 10 to the power minus 5 into sine 10 to the power 11 t. And what is the value of sigma? 10 to the power minus 3. The sigma value in the problem is 10 to the power minus 3. So the value is coming 100 sine 10 to the power 11 t, 10 to the power 11 t ampere per meter square. What is the value of the JC? JC value, this is the value of JR. How to calculate the value of JC? JC value we can get from JC value is equal to d by d into dt. What is d? d by dt into epsilon into E. What is the, we can also write epsilon d by dt into E. What is epsilon? E is 10 to the power 10 to the power 5 sine 10 to the power 11 t. So what is epsilon? Epsilon is equal to 2.5 into 8.854 into 10 to the power minus 12 because epsilon is equal to epsilon naught into epsilon r. So 2.5 into 8.854 into 10 to the power minus 12. What is the value of the E? E value is 10 to the power 5 sine 10 to the power 11 t. So d of dt, again 10 to the power 5 is constant, so we can write here 2.5 into 8.854 into 10 to the power 7 minus 7 into 10 to the power 11 into sine t. And if we solve this problem, this is the cos, this is not sine, it will come cos 10 to the power 11 t. And if we solve this, we will get the value of the JC. So how to get this? First one is the sigma E, and then we have to change it into the sigma E is equal to, sigma E is the conduction current density, and what is the displacement current density? Displacement current density is equal to d by dt, d is equal to the epsilon into E. Next, in the same problem, sometimes they give the another part that when the part is in which frequency both the current will be the similar. At which frequency both current will be the similar. To solve this problem, we have to write JR induction current conduction current density is equal to displacement current density. Second part, calculate the frequency when JR is equal to JC, conduction current is equal to displacement current. So JR is equal to JC means we can write sigma E is equal to, what is the value of the JC? JC means nothing but the epsilon into E. So sigma E is equal to d by dt into epsilon into E. So we can also write d by dt means 1 by frequency, and frequency can be written as omega into E. What is omega? Omega is again 2 pi f, sigma 2 pi f epsilon into E. So E will cancel out and we can write sigma is equal to 2 f into epsilon. So what is f? F is equal to sigma by 2 pi epsilon, or sigma by 2 pi epsilon naught epsilon r. What is the value of the sigma? 10 to the power minus 3 by 2 pi 8.854 into 10 to the power minus 12, and epsilon r value is given as 2.5, and the unit will come as hertz. So this is the another important problem from this chapter. Next we will discuss the question number 8. The loop shown in the figure is inside a uniform magnetic field 50 ux milliweber per meter square. If the DC of the loop cuts the lines of flux at a frequency of 50 Hz and the loop lies on the YZ plane at t equals to 0, find the EMF at t is equal to 1 second. This problem already came in the 2018 in IARE exam. In the 2017 IARE exam. This problem is a little tricky problem. So you can see this is a loop where it is 4 centimeter. This is the 4 centimeter, and the height is 3 centimeter. It is given that the B is equal to, the flux density is equal to 50 U. X means in the direction of the B is in the X direction, and it is the 50 milliweber per meter square. So we will again use the formula E is equal to BLV sin theta. So first B value is given. So BLV sin theta can be written as the B cross V into L. So B cross V, we have to calculate the B cross V. So what is the value of the V? It is given in the problem is B or U is equal to dl by dt. What is the dl? Rho into d phi, because it is in a uniform magnetic field. So rho d phi by dt. So we can also write it as rho omega into a omega. What is rho? Rho is the AD. This is the rho because it is a cylindrical in nature, and the height is given as the AD, and this height is given as the 4 centimeter. What is omega? Omega is equal to 2 pi f, and f value is given as the 50 hertz. So omega is equal to 2 pi into 100 pi. So what is the again flux density? How to calculate the flux density? B naught into AX. So we can tell B naught is equal to cos pi A rho minus sin phi A phi. We are changing the X value in the A rho and phi direction. So what is U cross B? U cross B means V cross B. So how to calculate the V cross B? A rho A phi A Z 0, A phi value is rho omega 0, B naught cos phi minus B naught sin phi 0. So if we do the cross product, we will get 0.2 pi cos phi dz. So what is the BEMF? BEMF will be, what is the value of the BEMF? Integration of Z is equal to 0 to Z is equal to 0.03 minus 0.02 pi cos phi dz. And what is the range? Range is from 0 to 0.3. We are calculating along the YZ plane. So it is given as the 0 to 0.3. And after integrating, we will got the BEMF is equal to 6 pi cos phi millivolt. So BEMF is in the, if it is Y plane, it will be the 90 degree apart, and it will comes as the BEMF is equal to 6 pi millivolt. So it is a little tough problem. First we have to calculate the EMF, and we know EMF is equal to E is equal to V cross B into L. So DL is equal to DL DC. What is the L? L is in along the Z axis, and we are writing as the DL DC or DZ. What is U? U is equal to the velocity is equal to dl by dt. Dl value is given rho d phi by dt. So if we put the value, we will get P omega A phi. What is the value of the rho? Because this is the rho radius. Rho is equal to the AD, the rho is equal to AD, or we can write the BC also. So AD is equal to 4 centimeter, omega is equal to 2 pi, f is equal to 100 pi. What is B? B is equal to B naught into A. X is equal to B naught cos phi A rho minus sin phi A phi. So U cross B. So what is U cross B? U cross B is equal to rho B naught omega cos phi dz. So 0.2 cos phi dz. So what is the BMF? Z is equal to 0 to 0.3, and if we put the value, we will get the EMF value is equal to 6 pi cos phi millivolt. So this is the another important problem of this chapter. Now we will go to the another problem. A conductor of a length of 1000 millimeter moves at a right angle to a uniform field strength of 10,000 lines per centimeter square with a velocity of 100 meters per second. Calculate the EMF induced in it. Compute also the value of induced EMF when the conductor moves at right angle of 120 degree to the direction of the field. So already we have solved one problem on this. A conductor of the length of 1000 millimeter, conductor length L is equal to 1000 millimeter is equal to 1 meter, and the uniform field of strength is field strength B is equal to 10,000 lines per centimeter square, or we can write as 1000. We can write is at 10 into 10 to the power 3 Weber per centimeter square, or we can write 10 into 10 to the power 3 into 10 to the power 4 Weber per meter square. So we can write that 10 to the power 8 Weber per meter square. So we got the value of the B. So what is the induced EMF? E is equal to BLV sin theta. What is the value of B? B value is given here 100 meters per second. 100 meters per second. So B value we got, L value we got, B value we got. So we can get the value of the induced EMF. Now, if we want to, and what is the theta? Theta value in the first case is given is the 90 degree, because the conductor moves at the right angle. The conductor moves at the right angle. Then we can get the value of the E is equal to BLV sin theta. Next important thing is we can also get the next case, theta is equal to 120 degree. So what is E? E is equal to BLV sin 120 degree, and using this formula we can get the EMF E is equal to BLV sin 120 degree, and if we put the value we can get the value of the induced EMF. Sin 120 degree is half. So this is another important questions from this chapter. Next we will discuss about the Maxwell's law. What is the Maxwell's equation and what is the we will discuss about the Maxwell's fourth law. So what is the Maxwell's first, how to assume the Maxwell's law? An electric current I, or a charging electric flux through a surface, produces a circulating magnetic field around any path that bounds, and from the third law we got the grad cross H is equal to, we got the equation grad cross H is equal to J plus del D by del T. Actually from the Ampere's third law we will got that grad cross H is equal to J. But now we can see that the current is not only the conduction current, always there is a displacement current. So we can write this is the JR plus JD, and JR is generally written by J and JD is equal to D by dt. So these are the assumptions of the Maxwell's law. Then we know from the Gauss law that the psi is equal to integration of the B ds, and from the Faraday's law we know that E is equal to minus d phi by dt. If there is a rate of change of flux, this is the north pole and south pole is continuously changing, and if there is a rate of change of flux, there is some induced EMF will comes. So E is equal to minus d phi by ds is equal to minus B ds by dt. B ds by dt. So again we know E is equal to integration of EDL, and integration of EDL is equal to dB by ds. So if we compute the two things, we will get E dot dl is equal to minus S dB by ds. This is the integral form of the Maxwell's law. Now if we apply the Stokes theorem, we will get integration of EDL is equal to grad cross E. So grad cross E is equal to integration of dB by ds by dt. So ds will be cancelled out from each other, and we will get grad cross E is equal to minus del B by del t. So this is the another important questions, and here we are also having some assumptions. And what are the assumptions? Changing the magnetic flux through a surface induces an electromagnetic force in any boundary path of the surface. We are assumed that the magnetic field only induces the EMF at the boundary condition. A changing in the magnetic field induces a circulating electric field. It gives a circulating electric field. The voltage accumulated around a closed circuit is proportional to the rate of change of magnetic flux that encloses. A circulating magnetic field is produced by an electric current, and the electric field that changes with time. So we have the four assumptions. And what is the Ponting theorem? Ponting theorem states that the rate of change of energy transfer per unit volume from a region of space equal to the rate of work done on the charge distribution in the region plus the energy flux leaving the region. So what is the Ponting vector? The Ponting vector, named after the John Henry Ponting, is used to demonstrate the energy flux density of an EM electromagnetic field. As per the definition, the Ponting vector is the result of the vector product or curl product of the electric field and magnetic component. We can write the Ponting theorem P is equal to E cross H or E H sin theta, and the direction is in the is according to the perpendicular of the EH plane. So in my today's session we have discussed some important problem, the definitions of the Maxwell's law and the definitions of the Ponting theorem. So thank you all.
Like, share and subscribe. Hit the bell icon for more updates.